Okay guys, I'm just gonna make a real quick video just to practice this here. So in your problem set number 1, question number 1 says, how many moles of xenon do 5.66 times 10 to the 23rd atoms equal? So if I was doing this question, here's my work right here. I'd say problem set number 1, and I gotta remember this fact. In 1 mole, there are 6.022 times 10 to the 23rd particles. And when they say particles, they just mean molecules or atoms. Sometimes they just use those interchangeably. So in question number 1 here, they say you're given that many atoms. So I always just write down what they give me right away. And then I'm gonna use this fact. So I write down what they give me, and I'm gonna use this fact. And remember in math class, if you ever have something on the top and the bottom, like if you ever had the number 7 times 1/7, just like that, that would cancel, and that'd be equal to 1. So my goal is, if I wanna get from atoms into moles, like the questions asked me to get into moles right there, I gotta have atoms on top, or whatever, atoms, particles, or molecules, and I gotta have atoms on the bottom. So I always like to do like this little crisscross here. And so I write down what they give me, 5.66 times 10 to the 23rd atoms of xenon, and I know that I wanna have atoms on the bottom right here. So I'm gonna say, okay, that must mean there are 6.022 times 10 to the 23rd. And since they were talking about atoms, I'm going to put atoms right here. They could say atoms or particles or molecules. So I know that many atoms of xenon I have in 6.022 times 10 to the 23rd atoms of xenon is 1 mole. And sometimes for mole, they'll put like MOL, but MOLE is fine. So xenon. So they gave me that many atoms, and for every 1 mole of xenon, I have that right there. And notice in the top and bottom, I have atoms and atoms. So when I times this through, that times that divided by that, it times across the top and divided by whatever's in the bottom, I'll be left with moles of xenon. So I'm gonna do that real quick. And I have this calculator right here. Oh shoot. I'll use this calculator because that might be the one you guys have. So I'm just gonna say 5.66, and then I gotta get to my big E button right there because that's exponent, so I hit second E to the 23rd. Sometimes I hit enter, I don't know, it makes me feel good. And then I'm gonna times it by 1. It's not gonna change it at all. And then I'm gonna divide by 6.022 times 10 to the 23rd. 6.022. I gotta get the big E to talk to the blue, I gotta hit that to the 23rd. And I get for an answer 0.939. So if I was gonna round to 2 digits, that'd round up to a 4 right there. So 0.94. So that's 0.94 moles. That many atoms is 0.94 moles of xenon. And that's really all this little practice that's making you do. You're either going to times or divide. My reason I divided here is because I had atoms. I want atoms in the bottom, so they'd cancel the units, and then I'd be left in moles right there. Okay. One little thing, the next step is once you have moles of something right there, like we have moles of xenon, that's really powerful information to know. Note, once you know how many moles you have, you can figure out how many grams. So once you know how many moles, so this is not this problem set, but it's your next problem set, so you might want to look back at this video. So you have your periodic table, and you got to find xenon on here. It's a noble gas, so it's right over here. Xenon, and they say, hey, when you have a mole of xenon, we know how many grams that is. It's 131.3 grams. So once you're into moles, that's always your good first step, like get it into moles, okay? So this is just a side note. This is not on your homework today, but I'm just showing you the next step. So once you have moles, you'd say, all right, let's do a little crisscross here. Just like this, and we're just going to use the fact is, we know that in a mole of xenon, it's 131.3 grams. So I'm just going to write that down off to the side here. 1 mole. I'm just holding my phone. I don't have my stand for it. Xenon equals 131.3 grams. Just like that. So you have to use that fact. Now here's the thing. If you want to be in grams at the end, that means if you're in moles right here, how would we cancel off moles? Like would I put the mole on the bottom or the mole on the top? So think about that for a second. So I'm going to have to use the mole. I'm going to put the mole on the bottom. So 1 mole of xenon. And sometimes for mole, they'll just put MOL. I was a little lazy there, but MOLE is fine. And 1 mole of xenon, you have 131.3 grams of xenon. So this, like I said, this part's not on your problem set today. So I'm just showing you for the future. Your next problem set 0.94 moles times by 131.3 equals, and then technically you divide by 1, but it's not going to change at all. And that's 123.42 grams. So if you had 0.94 of a mole, that'd be 123.42 grams of xenon. And I always box my final answer. That was a bad box. One little thing, doesn't that kind of make sense? If you only have like 94% of that right there, so a whole mole is 131.3, but you only have 0.94. So that times that divided by 1, that means you only have 123.42 grams. So you don't have quite a whole mole of xenon. Okay? So what you're doing in your homework today is mainly saying, hey, I have this many atoms divided by Avogadro's number to get to moles. So you're going to do a couple of those over and over again. This is for the future right there. So if that bugged you, you might want to look back at this later. But the last one I want to go over, a little bit tricky right here, number 5. So let's just read number 5. It's not really tricky, but I'm a little winded because I'm fighting a little cold here. But determine the number of moles of each specified atom or ion given the samples of the following compounds. Hint, the formula tells you how many atoms or ions are in each of them all. So lots of words, right? So the first thing you should always do is write down, all right, they said in 5A, you have 3.161 times 10 to the 23rd, or sorry, 10 to the 21st molecules of CO2. So you have that much, that's that much stuff. And you're like, whoa, I have that much stuff and I have to use this fact because they want me to get into moles, okay? And on this question, I'll mention that in a second. I do something kind of tricky, but first things first, I'm going to take this, I'm going to do my little crisscross, and I got to use the fact that there are 6.022 times 10 to the 23rd molecules CO2 and 1 mole of CO2. It's very much the same as what we're doing. We're just dividing by Avogadro's number right there. If you're like, that many molecules and 1 mole of CO2, I have that many molecules of CO2. So you're like, okay, I'm going to cancel my units just like that. And then you're like, okay, I'll type it in 3.161. 3.161. Got to get to the E, so I hit second E. So 21. Sometimes I'll enter right there. And then times 1. You don't need to do that necessarily, but I'll just do it because I'm a physics and math teacher and chemistry. Divided by Avogadro's number 6.022 e to the 23. And you can always arrow back there. 23. Boom. And you get something like this. It's 0.00524. 0.00525 technically moles of CO2. And if you look at the key, you're like, what the heck? I didn't get the right answer. And you look over at the key, and I think I posted this key for you. It says, oh, it's that number right there, moles of oxygen. So this question, if they just asked in this question right there, they said, how many moles of CO2 is it? You would be done, because that's how many moles of CO2 it is. But there's just an extra step. And if this bothers you, don't lose sleep over it tonight, because if you can convert from molecules to moles, this means we're good. But one little thing, there's 0.00525 moles of CO2. That's what you came up with, right? But one little thing, and I'll say this and we'll move on, that in 1 mole of CO2, how many O's do you have right there? You have 2. And it's kind of a little ratio there. So what you have to do is you times that, and divide by 1. And sorry for my atrocious handwriting. I'll show you right here. So I just take my answer, and you're like, oh, I'm going to times it by 2. Times it by 2 equals, and divide it by 1. And you're going to get, oh, so that's how many 0.0105. So 0.0105 moles of O2. And if you look at the key, then they kind of write it kind of funny. They write it in scientific notation, 0.0. That -2 just means you click the decimal, click 2 spots left. So that's actually the same answer as what I just got right there, 2. Okay? One thing you'll notice on part B it says C atoms in that. This is kind of the same question, but it's asking for the C atoms. Well, one thing about the C atoms is there's only one C atom, so you don't have to do that weird ratio thing because it's just going to be 1 to 1. If this part bothers you, don't lose sleep over it. We'll talk more about that in the future. But if you can do the first 4 here, that's the biggest deal, okay? And good luck, but I'll say the first 4 are the most important, and then when we give you the new problem set, you might want to look back about this part right here. Good luck. Email me if you have any questions, okay? But the big thing is this. You're just basically using this ratio right here and deciding how to put it so that it cancels off properly so you're left in the thing they're asking for. Good luck.